how to find out what they are and how they light up, do some research. So we have a little boy sitting by a computer and he looks like he's doing some research. Let's see what we do to research our what we're studying. Often scientists ask themselves, what do other scientists know about this? To find out, they do research. When you research, you use, I'm going to underline that. When you research, you use reference materials and talk to experts to learn what is known. So if you want to learn about scientists, know about firefly. If you want to learn what scientists know about fireflies, you can do these things. Use an encyclopedia, read a book, read science articles, visit a museum, email a scientist, visit science websites. Now, notice it didn't say anything about search on Wikipedia. Look at some strange website. Make sure you're looking at science websites. You're looking at the actual encyclopedia to do research. Those are important, that you're not coming up with things that might not be true just because it's written on the internet. These kinds of resources may have plenty of information about fireflies, but you still have questions they do not answer. That is when you conduct your own investigations. Let's look at this picture. It's of a natural history museum. You might have been to one before if you've gone to the Cincinnati Museum. Has some really cool stuff like this. Boonshoft has a little bit of it. Maybe you've gone out of town to maybe Chicago or Washington, D.C. and seen some really cool natural history museum kinds of artifacts, like this giant bug that these kids are looking at. I do see some kids on our Zoom nodding their heads that they've done that before. Very cool. Natural history museums have insect collections as well as scientists who can answer the questions about them. Even if you go to the Cincinnati Zoo has a really cool insect section where not a lot of zoos have that, and it's like an entire building just about insects. And I'm sure there's plenty of zoologists or scientists there to answer your questions. Let's go ahead and skip this question at the bottom and turn the page to page 34. We're going to talk about science tools. What comes to mind when you hear the word tools? Hammers, saws, and screwdrivers? What about computers and calculators? These are both science tools. Scientists use all kinds of tools to collect, record, and analyze information. Many turn the 5 senses into super senses. Tools enable scientists to see things that are far away, to smell faint odors, to hear quiet sounds, and to feel vibrations their bodies can't. Let's say you want to observe craters on the moon. A telescope is an example of your tool, which makes faraway objects look closer. It will turn your sense of sight into supervision. So a telescope is an example of a science tool. We've talked about hand lenses before in the first quarter. They are basically what you think of as a magnifying glass. An ant looks larger in a magnifying box or with a hand lens. You're just magnifying or making it greater in size from the way that the glass is bent. It actually makes it look larger than it is. When you are interested in studying tiny critters, such as leafcutter and ants, use a hand lens to collect information and to better analyze these ants. Hand lenses make small objects look bigger. Is the ant crawling away too fast to see it with the hand lens? Try gently placing the ant in a magnifying box. The top of the box has a lens in it too. Wondering what the ant's bite marks look like? Place a tiny piece of cut leaf under a microscope. A microscope is a tool for looking at objects that cannot be seen with the eye alone. So you technically could look at a microscope and put your finger on it and it would look really blown up and see basically what your eye cannot see when you are just looking at your finger. Mostly they're looking at like microscopic kinds of organisms, like dust or cells. They're looking really up close because your eye cannot see it if you're just trying to look at it in front of you. So before we answer this question, let's go back 2 pages to page 31 and write down lesson vocabulary of microscope. M-I-C-R-O-S-C-O-P-E. Microscope. I'm going to give you a moment to write that down. Again, I'm on page 31. Page 31. Microscope. All right. Turning back 2 pages to page 35. Predict how you could use a microscope to collect and analyze information about an ant. Make a drawing and add labels. So maybe information I want to find using a microscope might be, it's really hard to see what an ant looks like if it's really small. Maybe I want to see what its eyes look like. So I'm going to draw my little ant head with its like little antennae, and it's got like its first little body here, and then it's like back body there, and then it has 1, 2, 3, and then its legs maybe look a little bit longer. So I'm going to draw my insect, my ant. I want to collect information about it. So what I want to collect information on is what its little eyes look like. So draw a quick picture of what you would like to figure out. Eyes. I want to investigate its eyes. What kind of information? Maybe I want to compare different ants. Maybe if it's a different species of ant between like a regular, you know, those black ants versus like a fire ant, maybe its eyes look different from one another. And I could really kind of figure that out from an investigation with my microscope. So I want to compare eyes. Comparing eyes, but just a really quick picture. If you don't get done with this part, that's okay. You can always go back to it. Okay, so I'm going to go ahead and turn my page. You can too. Like I said, you can always go back and add more to your picture. Now we need to talk about measurement tools. What's the biggest bug in the world? How far can a grasshopper hop? How long can a butterfly fly? How do scientists find exact answers? I want you to really underline that. Not like predicted answers, not, you know, maybe answers, exact answers, okay? Scientists use measurement tools to collect, record, and analyze information to make their observations more exact. Think about it this way. You and your friend watch 2 grasshoppers hop. Your friend says, this one jumped farther, but you think that the other one jumped farther. To find out for sure, you need to measure. There are tools to measure length or distance, mass, force, volume, and temperature. So length, remember, is the same thing as distance. Mass is the weight of something. Force is how much basically pressure it puts on an object. You can think all the way back to like push and pull from like earlier grades. Force is that push on an object. Volume is the space that the object takes up. A lot of times we think of volume being liquid inside of a water bottle. That would be measuring volume. And temperature is how hot or cold. Most scientists use metric units with these tools: meters, kilometers, grams, kilograms, did I say liters, milliliters, centimeters, all sorts of different combinations of metric units. For example, a pan balance is used to measure mass with units called grams. A spring scale is used to measure a force in units called newtons. So look at these. We might seen something like these before. The one on this side, the blue one, you have maybe, and I'm predicting that you have seen a balance like this. You put an object on one side and the other object on the other one, and you see which one weighs more or if it'll equal out. Place the object you want to measure on one pan, add gram masses to the other pan until the two pans balance. So that you're trying to find how much it weighs by doing that. Add the masses together to find the total in grams. We also have this triple beam balance. A triple beam balance measures mass more exactly than a pan balance. It has just one pan and 3 beams. To find the mass in grams, move the sliders until the beam balances. So at the doctor's office, this kind of reminds me of if they have an older scale where you step on the scale and they move your weight across the top until it reads the correct weight. If you've been on an old fashioned scale like that, this is what that's kind of reminding me of. So let's go ahead and go over to tape measure and meter stick. These tools are used to measure lengths in millimeters, centimeters, and meters. So I'm assuming you've seen a tape measure before. You know, you can pull out like this, or it is like kind of not like a string, but like a little bit more flimsy than the ones that come out from a hardware store. And then there's also, like they said, a meter stick. Looks like a yardstick, but it's a meter stick, and it shows, often it's wood, shows how long a meter is. A spring scale is what we've already kind of talked about, being measured in newtons. It hangs an object from the hook at the end. This is the hook, and this is, you're kind of holding it like this. The marker, as the spring stretches, the marker will show the size of the force in newtons. So it's seeing how much the pull of gravity is pulling that object to the floor or wherever you're holding it. So whatever object you're putting on the end of this, obviously we know gravity makes things fall. If it's going to be on the end of this hook, it's really pulling, and we're seeing how much pull or how much force is being shown measuring wise, okay? And then a thermometer, we're all familiar with a thermometer. You can either measure in Celsius, which is metric, or Fahrenheit, which is F, which we do. So today it's 30, maybe 35 degrees out. In Celsius, if I were to find 35 degrees, it would say that it's like, let's see here, 35 is about 5 degrees Celsius. So it's a big difference between what we see. Much of the world uses Celsius. Again, like we use customary measurement, we're using Fahrenheit. Okay, we're going to skip the do the math portion and see more science tools so that we can kind of work on some of the activities together today. The wings of a hummingbird beat rapidly. Again, I'm on page 38. Wings of a hummingbird beat rapidly. A river surges through a canyon. Light reflects off of a mirror. Science tools help scientists observe nature in action. Many science tools help scientists make detailed observations in order to collect and record information. A camera is a tool that provides scientists with a permanent record. Scientists can use cameras to record the progress of a science experiment to analyze later. Still images help scientists study details. For example, pictures of a shadow can show how they change over a day. Scientists may use video images to study animal behavior or other moving objects. For instance, they may use slow motion video to observe the rapidly moving wings of a hummingbird. Other tools help scientists observe events or living things that are different to see with the eyes alone. Geologists may use a stream table to model the movement of sediment in water. A collecting net can be used for up-close observation of living organisms. Physicists use mirrors to study and analyze how light behaves. In addition to the tools shown on these pages, scientists use many other tools to collect, record, and analyze information. So we have a camera. Obviously, we're familiar with cameras. Stream table. A stream table is a type of model scientists use to observe and collect information about how water moves in sources too large to study in person. Now, if this was like a normal year, we would have maybe gone to the land lab behind what's it called, Southdale Elementary, over off the other side of Dorothy, and there they have a couple of stream tables that we could have seen how water moves in that object. But there's always the opportunity in later grades that you might see something like that. It's just basically a big table and you watch. It's got sand in it sometimes it's got other kinds of objects, and you just watch how the water goes through that table, and then scientists record data on it. They already talked about mirrors, about how light reflects and refracts off of these mirrors, and you're going to learn a lot about light movement and sound movement in the 5th grade when you go to Mr. Kleinhens's class next year for science. Collecting net. Ooh, you guys are probably really familiar with that with the butterfly unit in 3rd grade. How fun was butterflies with either Mrs. Meyer, Mrs. Ulrich, Mrs. Walkiewicz? You guys probably got to do the butterfly nets out at Caesars Creek. So that is for catching specimens, bugs, small creatures in general, without causing any harm. Okay, I am going to turn the page. We're going to talk about recording and displaying data, and then using data. So I'm going to go through these two pages really quick, and then we're going to go through some of the work. Our science block might go a little bit later than we normally do, okay? You're crawling through a tropical jungle. A butterfly flutters by, then another one appears. How will you keep track of how many you see? So there is, they've done a diagram. We've learned about that in text features, a picture with labeled parts. She has labeled the parts of her ladybug. I mean, I guess that's a boy, his ladybug. All right, recording data. The bits of information you observe are called data. Some data are in the form of numbers. For example, the number of butterflies you see in an hour is a piece of data. Other data are in the form of descriptions. Examples include written notes, diagrams, audio recordings, and photographs. Only observations are data. So when you think there are more butterflies here than in Canada, that's just a guess, guys. That's not data. By you just guessing that there's more butterflies here than in Canada, you have no data to prove it. That's just a guess. Data displaying our data. The data you record as you investigate may be correct, but not easy to understand. Later, you can decide how to display the data. For example, you might want to use your scribbled notes from the jungle to draw a map showing where you saw each butterfly. You might compare the number of each kind of butterfly you found in a circle graph. You might use a bar graph to show the number of butterflies you've seen in each hour. So we've seen kind of tables and graphs like this. This is a table on the left, and on the right, there is a corresponding bar graph that goes with some of the data. We can now fill in the bar graph based on this table. So they've done A, which goes to 3 number of flaps in a row. B, butterfly B does 9 wing flaps in a row. Butterfly C, let's do 4. We draw a line up to number 4. And I'm not going to color mine in. I'm just going to draw a little box like that. Looking at D, butterfly D also only does 3 flaps in a row, as well as E does the same amount of flaps in a row. Butterfly F, though, kind of blows the other butterflies out of the water by doing 10 flaps in a row. Okay, so we've completed the graph by using the table and filling in our information. If you were to look, the table does have some really good information, but the visual of my bar graph is more easy to read, and I can interpret it faster. I can look at it and determine really quickly, oh, butterfly F flaps its wings the most in a row, but butterfly A, D, and E do it the least amount, and they are the same basically. Not the same butterfly, but they're doing the same behaviors. All right, I'm gonna let you fill in your bar graph really quick. Okay, I'm going to go ahead and turn the page. We have one more part of information. You can be filling out the rest of your bar graph in a little bit. Follow along with where I am on page 42. We're using data. You see on the news that the number of honeybees in the United States is decreasing. What is happening to them? How do scientists use data to solve problems and share information? We're drawing conclusions. You've recorded your data. You've displayed it in a way that is easy to understand. Your next step is to analyze or look for patterns in the data. You might identify a trend or a direction in the data over time. For example, you might conclude that the number of honeybees in your hometown has decreased by 30% in the last 5 years. What's next? Communicating. Now, this was a question on your Google form yesterday that we missed a lot. Communicating, remember, guys, is talking to one another about our findings. Scientists communicate in many ways. They may work together to collect data. They compare their data with other scientists doing similar investigations. They report their results and conclusions by giving talks and writing reports. Conclusions often lead to new questions to investigate. Scientists are still studying why the number of honeybees is decreasing. I'm going to look. We have some pictures of our scientists sharing data. He's using an electronic device. We have these people over here. Scientists may work alone or in teams to analyze data and draw conclusions. Personally, I'd probably like to work in a team, but you might think to yourself, I prefer to work by myself. And then museums often have large collections of specimens, so scientists can compare what they have found to what is in a museum. People do that a lot. All right, and what we are going to work on, the 2 pages I'm going to have you take your pictures of, is the summarized page on page 44 and page 45. So let's go ahead and fill in this outline together. It's basically a summary of the lesson we just completed. We're just going to fill in the missing parts. So what are some other reference resources you can use? I have encyclopedias. What else can we use to do research? Charlotte.
We can also use to do research is we can like look on on a website.
Science websites. Science websites. I'll give you a hint, guys. They are on page, I had us underline them, or maybe you didn't underline them, but I underlined them on page 33. What are some ways I can research? What resources can I use? I need some help. We can really only go until like 1 o'clock on science, so I really need friends to help me out on this. William.
You can read a book.
Read a book. Books. What else? Hank.
Visit a museum.
Museums. What else? Olive.
Read science articles.
Science articles. One more. That's missing. Charlotte.
You're missing. Email.
What was that? Email. Yes. Email a scientist. Okay, science tools. Scientists use tools to make senses more powerful, tools that aid in the sense of sight. What were the tools that we talked about that are about sight? That's on the next page, the page that I drew my ant. Page 34 and 35. What are the different tools on 34 and 35? What tool did we use to measure an ant? Right? For our drawing. Eliza.
A microscope.
A microscope. What other tools did we use? Charlotte.
We also use a magnifying glass.
They called it a hand lens. It's kind of easier to do than a magnifying glass, but that is the same thing. Let me look. I have microscope, telescope, hand lens. Oh, and this one's kind of hard. William.
Magnifying box.
Magnifying box. Perfect. Magnifying box. Try your best on the spelling. This is, it's science. I'd like you to spell things correct, but I understand if we don't have a word like magnifying spelled correctly. Okay, now we have to say, what are these types of tools? It was on the page that we talked about pan balances, triple beam balance, spring scale, tape measure. What are we doing on that? Thinking of a tape measure. What are we measure? Oh, I'm sorry, I gave that away. It's a measuring tools. I gave that one away. What is the missing measuring tool? I'll give you a hint. How do I measure temperature? What tool do I use, Charlotte?
It's like this thermometer that like you.
Thermometer.
That people use it for pools to see if it's hot or cold too.
Thermometer. Did I spell thermometer correct? I don't think I did. Boop. Nope, there's one more M. And then put a little caret. Thermometer. More science tools. Then on the next page, we talked about cameras. Cameras, a stream table. We talked about a mirror. And this last one was what you used at Caesars Creek, a net, a collecting net. Ways to display tables. How can I display my table? I mean, not just tables, ways to display my data. That's on page 40 and 41. Page 40 and 41. Charlotte?
How you use data is
Page 40 and 41.
is you can okay, so what you can do is you can see, like, for example, like, well, over here it said butterflies, but like if you see how high a kangaroo, like if there's like different
Yes, but how am I going to display that? What am I using, William?
A graph.
A graph? And then the other one, we didn't draw it, but they talked about maps. We talked about maps. Okay, page 44 is one of the pages I'm going to ask you take a very nice, clear picture that I can see all of your work. I will return it to you if it is blurry. The other picture I'm going to ask is we are going to do word play. So you are unscrambling the words that are on the left into the hexagon on the right. So if I am looking, I've got a bunch of words at the bottom. For instance, ta-da is not going to be ta-da. Instead, it is data, D-A-T-A. I would go down to the bottom and cross off data. Okay, we're doing unscrambling. What about my next one? Or some of our other ones. Maybe you want to do a different one other than the next one. You're going to have to really think through some of them. I'm not quite sure what the next one is. I think I know this next one is research. RESEARCH is research. I go down to the bottom and cross off research. I'm going to give you 5 minutes to work on unscrambling the words. These are the vocabulary words that we came across in this lesson. Okay, so 5 minutes. Oh, James, I'm sorry. I didn't realize my screen didn't say you were in here. I apologize. I meant to send that to somebody else in GoGuardian. I apologize. All right, does anybody want to help me out with some of the ones that we need to unscramble? Eliza.
The last one.
The last one, which one is that?
Pan balance.
Pan balance, PANBALANCE, pan balance. Another one, William. Oh, you are on mute, William.
The fifth one.
The fifth one, 1, 2, 3, 4, 5. What is the fifth one? Krupsmice.
Microscope.
Microscope.
Notice that the one before the last one says meter mother.
I know, it's really funny. Microscope. Great. Where is my, oh, there we go. What's another one? Kira.
The fourth one is circle graph.
Circle graph for the fourth one. Perfect. What's another one? Olive.
Meter mother, which is thermometer.
Yes. Meter. Thermometer. Like she said, the one that says meter mother. What's another one? Mason.
Number 6 is spring scale.
Spring scale. The one that says grapes plan. Spring scale. Underneath microscope. Great. Now we're kind of dwindling down. I'm thinking Sophia.
The 8th one is magnifying box.
Magnifying box. You are correct. Magnifying box. NIFYING and then box BOX. Magnifying box. Tape measure, communicate, and that's what's left. So is it tape measure would be this one because it's 2 words, TAPE, and then measure, MEASURE, and then communicate, COMMUNICATE. Okay. So my page is filled out for 45. What I'm going to ask, again, I'm going to repeat myself on your classwork for today. I'm going to add an assignment that asks you to take a picture of page 44 and page 45 to upload to Google Classroom. I'm going to give you 10 points for watching the video / being here in Zoom. I'm going to make sure that I have the correct who's all here so that you guys get your credit for being here. I'm going to give you 10 points for being here or watching the video, and then you're going to get another 10 points, 5 for each page that you're turning in. So that's a total of 20 easy points that you guys are going to get, especially after yesterday when we had a little bit of a hard time on the thing that you guys turned in, the Google form. Maybe we weren't happy with our grades on it, what have you. So this should be some easy points once I add it to Google Classroom. And then I will, if you missed any of the Zoom, I will post the video to Google Classroom as well, so you can make sure you didn't miss anything from it. Now, all right, I think I have marked everybody that was here. So William and Liam and Carter, I'll see you tomorrow. The rest of my friends,